This is Unit 3 test video number 1. The Unit 3 test was about geometric and algebraic connections. The seismic activity density of a region is the ratio of the number of earthquakes during a given time span to the land area Let's write that down. So the seismic density, which I will call D for density, they're telling us is the ratio of the number of earthquakes, I'll put E for earthquakes, during a given time span to the land area. So density is earthquakes per area. Now, a state had 424 earthquakes. Okay, so that would be this number over a given time span and a land area of 71,300 square miles. What is the seismic activity density for the state round to the nearest 10,000th if necessary? Okay, that's 3 decimal places, by the way. Okay, so we're just going to divide these two numbers. That's all we're going to do. So we will go 424 divided by 71,300. Okay. So that's going to be, whoa. Did I say 3 decimal places? I meant 4 decimal places for 10,000ths. Tenths, hundredths, thousandths, 10,000ths. So 0.0059. Earthquakes per square mile. Okay, what is the value of x? Well, we know that the sum of the angles inside of a quadrilateral should be 360 degrees. Now that's one you should memorize, just like the sum of the angles in a triangle are 180. But remember, you can use the formula n minus 2 times 180 to figure out the total number of degrees inside of any polygon. Okay, so if I wanted to know how many degrees are in a quadrilateral, if I didn't remember it was 360, that's 4 sides, so I could just do 4 minus 2 times 180. That would be 2 times 180, and that would be 360. But if instead of a quadrilateral, say if it had been a pentagon instead, then I still could have figured it out by doing, by doing 5 minus 2 times 180. And that would be 3 times 180. And let's see what that would be. 3 times 180. I missed. 3 times 180 would be 540. Okay? But in this case it was 360, so let's stick with that. So that means the total of all these angles should add up to 360. In other words, 110 plus 70 plus another 110 plus 5x should all add up to 360 degrees. Let's see what these 3 add up to be. Okay, 110 plus 70 plus 110. So far that's 290. So I've got 290 plus 5x should equal 360. Then I would subtract 290 from both sides. So that's going to give me 5x equals. Alright, so I have 360 minus 290. That's 70. Okay, then I would divide both sides by 5. That's 14. So that should be the value of x. There you go. What is the equation of the line that is parallel to the given line and passes through the point -2, 2? By giving you a line that is parallel to the one we want an equation for, this is just an indirect way of giving you the slope. Alright, that's all it is. Because parallel lines have the same slope. So if I look at this line, if I know the slope of this line, I'm going to know the slope that I want for my line. Now they're giving me these points right here, so I could do the slope formula, which I will do off to the side here. The slope formula is y minus y over x minus x. And I guess usually they will say y2 minus y1 over x2 minus x1. So I'm going to call this point 2, and I'm going to call this point 1. So if I wanted to use my slope formula, I will do y2 minus y1. So that would be -3 minus -4. And then I will do 0 minus -5. So 0 minus -5. Now I know when I do minus and negative, it's really addition. So it's really -3 plus 4 over 0 plus 5. So that's going to be -3 plus 4 is 1. And 0 plus 5, of course, is 5. So the slope is 1/5. Okay? So now as far as I'm concerned, in my opinion, there's an easier way to find the slope when they're kind enough to give us a graph like this. Just do rise over run. So I'm noticing that this, as I travel from one point to another, you would have to go up 1 and over 5. So there's your slope of 1/5 right there. By the way, because it's going uphill from left to right, you know it's going to be positive, which just helps you out. Either way, by giving us the word parallel, they are indirectly giving us the slope. So now what we have is a slope and a point. So if I want an equation, I can use something called point-slope form. And point-slope form of an equation looks like this. You can do y minus y, well, I guess they usually say y1. Y minus y1 is equal to the slope times x minus x1. Now the slope is the m. Okay, so that means the 1/5 is going to go right here. Okay, now the y and the x just stay what they are. Now the y1 and the x1 are a point. Okay, so this is y1 and this is x1. Okay, so the negative sign in this formula, these negative signs tell you to do the opposite sign. So this is a +2, so I will put -2 right there. This x is a -2, so I will put +2 right there. Okay, so this is an equation for the line that is parallel to this. So if they want the line to be in point-slope form, that's it. So I'm going to go ahead and look at some of these answers. They seem to be in slope-intercept form. They seem to be in the form y equals mx plus b. So I will keep going and rewrite this in slope-intercept form. So if I want to do that, what I need to do is I need to do the distributive property with the 1/5. Okay, so if I do that, I've got my y minus 2 equals. Now 1/5 times x is just 1/5 x. 1/5 times 2 is just going to be 2/5. Okay, just doing that off to the side, understand if I'm doing 1/5 times 2, that's the same thing as doing 1/5 times 2 over 1. And when you multiply fractions, you just multiply straight across. So 1 times 2 is 2, 5 times 1 is 5. That's where I'm getting a 2/5 from. Okay, now I'm going to subtract 2 from both sides to get y by itself. Sorry, it's already being subtracted. I'm going to do the opposite and add 2 to both sides to get y by itself. So that's going to give me y equals 1/5 x plus, so now it's just a matter of what 2/5 plus 2 is. I'm going to cheat and use my calculator to help me. I mean, obviously I could do it by hand, but you know, we all have a calculator, we're allowed to use it, so this is probably what most of you would want to do. So 2 plus 2/5, alright, that is 12/5. Okay, so this would be an equation for the line that is parallel to this line and passing through the point -2, 2. Okay, and you can see that this matches the second answer right there. Which point on the y-axis lies on the line that passes through the point G and is parallel to line DF? Okay, let's see, let's start with this. We're talking about a line that is parallel to line DF and passes through the point G. So DF, let's talk about the slope of this line. So I'm going to put a few extra points on here because I can see it's crossing evenly at this point here and this point here. So when I want to talk about the slope, I'm going to notice that this line is going uphill. As I go from left to right, it's going uphill. So I know that this is a positive slope. Alright, so I know this slope is going to be positive something. Now, rise over run. So I'm going up 2 over 1, up 2 over 1, up 2 over 1. So that means my slope is positive 2 over 1, and 2 over 1 is just 2. So I know I'm dealing with a slope of 2. Okay, now, so keep that in mind, up 2 over 1. Now, we're talking about a line that passes through the point G. Okay, so here I am at point G. If it's parallel, it should have the same slope. Alright, so I'm going to start at point G and I'm going to do the same slope. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So this is the line that passes through point G that is parallel to line DF. Alright, that is the crookedest line you've ever seen. But as you can see, right here is where it crosses the y-axis. So that's the point 0, 4. Okay, that's why this is the answer right here. Alright, given this picture, what is the measure of angle BCD? Angle BCD is this angle right here. So eventually, this is what we have to figure out. But before I get to that, I'm noticing that all the angles that we're given are exterior angles. Okay, and we know that all of the exterior angles of any polygon, including a quadrilateral, which we have here, the exterior angles add to 360, no matter what the shape is. Okay, so let's see. How many exterior angles do we have? Okay, so I've got, boom, 1, 2, 3. Alright, the only exterior angle that I'm missing is this one right here, which I will call Y for a moment. Okay, that's the only missing exterior angle. I've got this one, this one, this one. There are 4, so I'm missing the 4th one. So the sum of the exterior angles, including Y, should equal 360. So let's go ahead and find Y, and then it should be a simple matter to find X. So let's see, 146 plus 25 plus 149 plus, I hate it when it does that, plus Y should equal 360. Let's go ahead and see what these 3 add up to be. That rhymes. Okay, so that's 146 plus 25 plus 149. All right, that's 320. So that's 320 plus Y is equal to 360. So if I want to find Y, I am going to subtract 320 from both sides. So that's going to be 40. Okay, but that is not the final answer because what we found is the missing external angle. But what they actually asked us for, BCD, is an interior angle. These 2 angles form what is called a linear pair. Hopefully you can see that together they make a straight line, which means that together they make 180 degrees. All right, these 2 angles here together make 180 degrees. So if angle Y is 40, but I want to find angle X, all I have to do is subtract from 180. So 180 minus 40, that should give me the angle X. So that's going to be 140. All right, so that should be your answer. All right, in this problem we are being asked, what is the area of the trapezoid? Now normally as soon as I see that, I'm thinking, okay, I know the formula for the area of a trapezoid. It's similar to the area of a triangle, which is 1/2 base times height. But for a trapezoid, we have 2 bases, so it's 1/2 the sum of the bases times the height. So instead of 1/2 base times height, it's 1/2 bases times height. The problem is both of my bases are diagonal. I don't have any bases. Neither base is horizontal or vertical. And then the height, it's just a mess. Like the height is going to be slanted, the bases are slanted. So this is not going to be the easiest way to go for this problem. So whenever you have a figure and all your lines are slanted, nothing's horizontal or vertical, your best bet is to use the box method. And that's where we're going to draw ourselves a rectangle very tightly around the shape so that the vertices of the figure are each touching one of the sides of the rectangle. So what that does is it creates little triangles around the shape. So I've got a triangle here, and I will call this triangle number 1. And down here there's another triangle, I'll call that number 2. And there's another triangle here, I will call that triangle number 3. And another triangle right here, and I will call that triangle number 4. So what you have to realize is that if I want the area of the trapezoid, what I can do is start with the area of the rectangle, and then subtract the 4 triangles. Alright, because think about it. Imagine that this highlighter was scissors. If I took these triangles and I cut them off, alright, imagine that I just cut that off. If I cut this off, and if I cut this off with scissors, and those triangles are falling to the ground, they're falling away. Visualize it, picture it. Alright, if I take away the triangles, what's left? All that's left is the shape that I actually want. So if I start with the area of the rectangle and cut out the triangles, or subtract the triangles, that should leave the area that I want. So this is a very powerful technique that works for lots of different kinds of shapes. So that's what I'm going to do. So let's organize our work. First of all, let's find the area of the rectangle. Okay, so the area of the rectangle, you know what, these numbers are in my way, they're bugging me. Deal with that later. Okay, so the area of the rectangle. So the bottom of the rectangle, the base, 1, 2, 3, 4, 5. And then the height of the rectangle is also 5. Alright, just counting squares. So, speaking of squares, it's a square. So that tells me that the area of the rectangle, which of course is 5 times 5, is 25. Okay, now let's find the area of each of these triangles. So first I'm going to find the area of this triangle. Alright, triangle 1. So remember, the formula for the area of a triangle is 1/2 base times height. Okay, so the base of this triangle, alright, let me get rid of some of this right here. The base of this triangle goes from here to here. Alright, that's 1, 2, 3, 4. And the height goes from here to here. That's 1, 2, 3, 4 again. So that's 1/2 4 times 4. Okay, 4 times 4 is 16. 1/2 of 16 is 8. So triangle 1 is 8. Okay, now let's do another triangle. Let's see. Alright, so that was triangle number 1. So this is triangle number 2 down here. So triangle number 2, the base of this triangle is 3, and the height is 1. So I'm going to do 1/2 base times height. That's 1/2 3 times 1. 3 times 1 is 3. Half of 3 is 1.5. So there's triangle 2. Okay, let's keep going. Alright, now let's do triangle 3. Alright, triangle 3 is like this. Okay, so here I've got a base of 2 and a height of 2. 2 and 2. So that's 1/2 2 times 2. 2 times 2 is 4. Half of 4 is 2. Alright, so one more triangle to do. Okay, so here comes triangle 4. Alright, now the height of triangle 4 is 3. The base of triangle 4 is 1. Alright, 3 and 1. So 1/2 base times height, so that's 1/2 1 times 3. Again, 1 times 3 is 3. Half of 3 is 1.5. Okay? So, if I want the area of the trapezoid, I'm going to take the area of my rectangle and I'm going to subtract all my triangles. Okay, so let's do this. Let us add up all the triangles first. Okay, don't do that. No, too big. So we have 8 plus 1.5 plus 2 plus 1.5. Alright, that's 13. Okay. So if I want to find the area of my trapezoid, it should be the area of the rectangle minus the area of the triangles. So that should be 12. And that's how it's done. Okay, what is the radius of a circle whose equation here is given? Well, compare this to the model, the standard form equation of a circle, which is like this. We have x minus h squared plus y minus k squared, and that is equal to the radius squared. In this form, the center would be h comma k. Alright, so by the way, so the center of this particular circle, alright, these minuses in the formula tell you to take the opposite sign. So the center would be -5 comma +3. Now the radius is the thing that's being squared. So the radius is not 16. The radius is 4. Okay, because it's the radius squared. This is 4 squared. The radius is 4. Okay, that's why this is the answer. Alright, this video is getting long, so this is going to have to be the last problem. So, which equation represents the circle described? The radius is 2 units, and the center is the same as the circle who has this equation. This is the tougher part, so let's go ahead and deal with this first. If I want to see what the center of this circle is, I need to rewrite this in standard form. The way to rewrite this in standard form is I'm going to have to complete the square. Okay, that's going to involve putting the x terms together, and it's going to involve putting the y terms together. Okay, so I'm going to match those up. The 24, I'm just going to have to move that out of the way by subtracting 24 from both sides. So watch as I reorganize this equation. So first of all, the x's. So I got x squared minus 8x. I'm going to put that over here. X squared minus 8x. Now I'm going to leave a space, leave a little gap there. Now here comes the y's. Alright, so now I'm going to have y squared minus 6y. So I'll put plus y squared minus 6y. Okay, so that's the y's. And again, I'm going to leave a space, and then I'll have my negative 24 that I moved out of the way. So now I'm going to complete the square twice. Okay, let's see. So the way you complete the square is you look at the middle term here. I'm going to take half of the middle, and then I'm going to square that. So half of 8 is 4. Okay, I took half, and then I'm going to square that. 4 squared is 16. That's why I'm going to put a positive 16 right here. Now, before I put the 16 in, I had a valid equation. The left side equaled the right side. If I'm going to still have a valid equation, if I add 16 here in green, I need to add a green 16 over there. I mean, obviously the color doesn't matter, but I put in a brand new 16 on the left. I've got to put in a 16 on the right to keep the equation balanced. Now I need to do the same thing with the y's. I need to complete the square. Alright, again I'm going to take half of the middle and I'm going to square it. Half of 6 is 3, and then 3 squared is 9. So I'm going to put a plus 9 on both sides. I really have to emphasize that because a lot of students will do a bunch of things right, but they'll forget to balance the equation. When you complete the square, you've got to put it on both sides of the equation. Now, the point of completing the square is so that when we factor, which is what we're going to do next, it should always factor as the same thing twice. So if I take this trinomial with the x's and I factor it, it should factor as the same thing twice. X squared, well, that's x times x. 16 is 4 times 4. See how everything is the same? It's just a matter of should they be positive or negative. Well, you can tell that by looking right here. If this is negative, then these will be negative. Same thing twice. Alright, that's what completing the square does for you. It guarantees that to happen. So, again, this trinomial right here should factor as the same thing twice. Y squared is y times y. 9 is 3 times 3. See the negative, so you know it's going to be negative. Okay, meanwhile over here, 16 plus 9 is 25. 25 minus 24 is 1. Okay, I mean you could use a calculator if you need to, but I'm just adding all these up and it makes positive 1. Okay, now again, the reason why it's significant that we have the same thing twice is because I can now write this in standard form. Instead of having x minus 4 twice, I can write x minus 4 squared. Alright, instead of having y minus 3 twice, I can write y minus 3 squared. And I'm hoping you see that this is now becoming the standard form equation of a circle. Now specifically the center of the circle, which is our whole point, was to get this center, is going to be the opposite of these. So it's going to be positive 4, comma 3. Okay? So we want an equation that has the same center. So really what they're telling us is that this part of the equation should be the same. Okay, let's see. I'll go with the light blue here. So if it has the same center, then this part of the equation should be the same. So I should have x minus 4 squared plus y minus 3 squared. That way it has the same center. Now, the easy part. The radius is 2 units. Now, in standard form, right here we put the radius squared. So if the radius is 2 units, then it should be 2 squared. Okay, or it might be written as 4. So either way, if I see, I should have this and either 2 squared or 4, because obviously that's the same thing. All right, let's reveal and see what we got. Okay, so whoops, I wanted back to yellow. They're indicating this as the correct answer. X minus 4 plus y minus 3 squared equals, and they went ahead and wrote it as 2 squared, which is, you know, same thing as 4. Alright, this video is quite long, so I'm going to stop it here. I hope this is helping you, and good luck on your test.